So now we take a look at definition of functions, the features, and what are different ways of creating them in Python. So as part of this module, we'll learn how to create and execute functions. We'll learn object-oriented programming. So why do we need functions? Until now, we very well know that we can also write code in this fashion on any Python script, wherein it's just a bunch of lines that get executed. But when if you have to write code in this format, I'd say write a function for factorial, or not write a function, just write piece of code that implements factorial. Also write a piece of code that implements palindrome and prints triangle in a certain format, creating a pyramid of 1 to 7, 1 to 8. So we can have multiple things specified in one script file. But if you write your code in this form without organizing it in functions, whenever you'll run the script, it will execute all these features at once, like factorial, palindrome, pyramid, whatever you are printing. Secondly, if you have to debug where or what are the lines that correspond to the factorial code, you'll always have to hunt around and see where did it start and where did it end. So often a good way to deal with these kind of problems is to organize your code. And when we say organize, that means why not give certain lines of code a name that is meaningful enough to explain what that piece of code does. So in this case, if we say define factorial and then write all of this code under that definition, that means these lines of code will generate a factorial of a number, and we just have to pass an input. So that way it's easy to refer that in future, and also it becomes more reusable and easy to debug as well. So that means we should learn how to create functions in Python. And what does the syntax of function look like? We use the keyword def is for define, followed by name of the function. In this case, print name is the name of the function. Open and close parenthesis, colon, and this requires indentation to be followed. So all lines corresponding to the function should have at least one indent, tab, space, or corresponding indent that you have decided for all your files. Now, these parentheses may take arguments as input from the user, or they may just be left empty if they already know what values they would be dealing with, and those are kind of static in nature. So if we write our first function, in this case, we do pass a bunch of parameters here. But what if we define a function like this? Define process, and we say read pointer, open this file, say open miscellaneous new test.json in read mode, and we say for line in RP, and we say print line. Once we are done with it, we say rp.close. So as part of this function, we are not taking any arguments from the end user. Every time it is going to open test.json, print all lines from test.json, and then close the file and come out of it. However, you can make your functions more flexible. If you want to utilize this for reading any kind of file, you can rather choose for getting file path as input from the end user, and then say open that file path. And you can make it more robust as well. You can say if os.path.exist, so if this file path exists, only then you are going to perform all this. If it does not exist, then to avoid any error, you have already put a check in place. So this way we can create functions, make them more flexible and reusable, not only in terms of revisiting them and excusing them, but rather making them more flexible in terms of passing the parameters and then reusing the same function to operate over different types of objects. So this is how we get started in defining functions in Python. Then extending that further, we define a new function called add, and we take multiple parameters as in. So we want two numbers for add function to run, and instead of defining one parameter like file path in process, we say n1 and n2 as two numbers in add function. And what we do within add, we just return the sum of those two values. So we have created this add function, and we are using input function to take input from the end user. We'll say 20, and then we say 30. It prints the output as 50. Now, in this case, when you look at the definition of add function, it's actually a very loose definition, as in we have not specified if we are adding strings or we are adding integers, but rather outside the add function we have hard coded or a base put, and every time we'll be converting the values to integer for add function to sum them up. So I would say it's handled if you define it as part of the add function, so that any other person who is going to use your code to see whether add function can be used to add numbers or it can be used to add anything like concatenating dates. Say within a Spark, Spark as a string as well, concatenated. So it all depends how do we want to implement it and whether we want conditions to be implemented outside the function or within the function. We have defined the function and now we want to use it. We have also seen how to use that function. You can now just call add 3 comma 4 and it's going to add the values. You call add Python and anaconda, it is going to add those values. So without any type conversion, it's going to simply add up the values. If you're passing two numbers, it's going to add those two numbers. If you're passing two strings, it is going to concatenate those two strings. Let's verify this. Let's verify this as well. And now let's verify one more case wherein you say add 3 comma Python. So in this scenario, it will fail. It says that greater than symbol is not supported between instances of integer and string, because we are checking if n1 is greater than n2, if n1 is less than n2. So in those scenarios, add function is not going to return any value. Now coming to some of the built-in functions. So the function that we have written just now, the add function and the process function, those were defined by us and we call those as user-defined functions. So that was our first function, and then followed by this, we will now learn different forms of passing arguments to a function. We say function arguments and we'll get started with that. So first we'll cover different aspects of user-defined functions and then we will touch upon different ways of passing arguments. So we have looked at functions that we have written and were returning a value. You could also write a function, define new, and then let's say this takes A and B as input and you just say return without returning anything. So there could be one variant that returns a value, second variant that returns but does not return a value, and there could be third that may or may not take any parameters and at the same time just says print hello world. So this one is not even attempting to return anything. So we can very well have functions like these, and when you call new and third you should print and we say new 1 comma 2 and we also print the output of third. So we are calling both functions in a single print statement and let's see how does the output look like. So it prints hello world, and since none of the functions are returning anything, the reason we see hello world prior to our print statement is it calls new and it calls third in one single print. While both are called simultaneously, the output of this print within the third function gets printed hello world, and because none of the functions are returning an actual value, third one is not returning, not even attempting to return, and the new one is attempting to return but it does not return any value. So both turn out to be none. That's equivalent of null or empty, definition of empty in Python. Now coming on to function arguments, and we'll touch upon lambda and the built-in functions after covering function arguments. So let's say you want to write a function that takes three inputs and you want to print that. We define that function as fun at the moment, and then we want to call fun function in multiple ways. So I'll first use a very common and conventional way of calling it, that is function fun, and passing 10, 20, 30 as input. Nothing else is getting executed in this block. So this takes three arguments and we are passing three values 10, 20, 30. That's pretty simple. Now want to split it so that we don't have to scroll often. So when we get this as the output, now let's say you want to pass 10, 20, 45 as the values, but then you want to assign it to the arguments explicitly. So that means you can also call your function in this form wherein you can say a is equal to 10, b is equal to 45 and c is equal to 20. The benefit of this notation is you don't have to follow an order. So there are different ways in which these arguments get interpreted. The first way is called positional notation, wherein we were passing values 10, 20, 30 and we saw output was also 10, 20, 30. That means 10 got assigned to A, 20 got assigned to B and 30 got assigned to C. The values were read from left to right and the arguments were also read from left to right. So the values were mapped to all the arguments. So leftmost value to leftmost argument and similarly rightmost value to the rightmost argument. So in this case, it is very important that we pass as many number of values as the arguments. So if we pass 10, 20, 30 and 40 instead of just passing 10, 20, 30, it fails. It says function takes three positional arguments, but four were given. So number of values should match the number of arguments. The second way of calling a function is we assign values to respective variables, and in that case, the positional notation does not come into picture. So if you try to draw an analogy here, this is very much similar to the features that we have learned on lists and dictionaries separately. We learned that until list, everything was being followed in a positional order. We can access elements in list using a positional notation by specifying index and slice. We could do that on tuples, strings as well. But dictionary onwards, we learned that positional notation had no relevance and values can be retrieved by specifying the key against which we want the value. Similarly, in this case, when it comes to passing arguments, you can take the argument name and assign a value to it, and the order does not matter. So the second form of calling fun is called keyword notation. And when we execute this, we see 10, 45, 20. So we said B is equal to 45, but that was specified at last, and C was specified prior to B. And now the third form of calling function in this case is we are passing all three values that are definitely required, and we are passing two additional key value pairs. Let's see what happens in that case. So it again returns an error saying got an unexpected keyword argument D because only A, B, and C are defined in the function definition. Now this was plainly speaking about a function definition that requires all values to be specified. So there are four type of value specifications on function arguments. So there are four specifications. One is non-default arguments. That means we have to specify a value. So say specify a value for every argument. And default arguments default to the value specified. So in this case, let's say we want C to have a default value of 100 and A and B we do not specify value. So how do we interpret this signature or how do we read it? We say A and B are non-default arguments and C is a default argument. That means if we pass value to C, that will override the default value. But if we do not pass any value for C, then it will fall back to its default value. So does that mean that we can even call this function now with just two values if we have the provision of not passing value for C? So let's try this and say 10, 20, and 30 first of all to see what output comes out. So C takes its actual value that we have passed, but instead of 30, let's call function 1 with just two values 10 and 20. So it falls back to default value of C. But then I realized instead of C, why not have default value for B and let A and C be non-default arguments? That means value to be specified. So does that mean when we pass 10 and 22 values, so 10 will get assigned to A and 20 will get assigned to C and B will take its default value? Let's see this. This will fail. So when it comes to function specification, it mandates that we follow this order. First of all non-default arguments should be specified separated by comma, followed by all default arguments. So this requires B to be specified in the end. If we specify that in between, somehow Jupyter does not show you that it's a syntactical error. But if you try it on PyCharm, so if we write this, you could see there is a red underline near C and says non-default parameter follows default parameter. So C is non-default and is specified after default value, which is not allowed. So it corrects you then and there itself. Jupyter does not have that ability. So in such cases, all non-default parameters should be specified before default parameters, even if you think that default parameter should be somewhere in between, but you have to follow this order. So it will not go by the naming convention or the line of parameters that you want to put up, but rather you should decide what is it that you mandatorily require as input from the end user and what is it that you can default to. So now when we execute this, it will say 10 and 20 being taken up by A and C and B is 100. That's because we are printing the variables in the order A, B, and C. If we print A, C, B, then it will again be 10, 20, and 100. So you could have any number of default parameters after you define the very first default parameter. So now when we execute this, there are no issues and you can actually print other parameters as well. And now we can look at other ways of passing arguments. So this way we know that you can have a combination and you can also have some flexibility in terms of only passing values for something that is mandatory. It is very often required in cases wherein you think you only require actual data to be supplied by the user on which some process has to happen. And there could be parameters that define that this has to connect to MySQL DB or Postgres DB, and all those details will actually be defaulted by you in the application, probably coming from a config file. So that way user don't have to worry about passing those additional values. User would only pass values for the non-default arguments. Similarly, you can have a method like this that says format name, first name, last name, and then you define the format. It should be printing either first name, last name. So if you say if the name has to be printed in the reverse order, you print last name followed by first name. Otherwise, you print first name followed by last name. Middle name is not made mandatory. So you have to have first name and last name. Middle name can be defaulted to none. If user supplies any value, it can be utilized, but at the moment we are not. Otherwise, it will remain empty. And then there is a reverse flag to say in what format you want name, whether it should be first name, last name, or last name, first name. See, you can try this function by saying print format name Python Spark and reverse is equal to true. So that prints Spark Python. And if you say don't specify the reverse, that means it has to print name in the actual order, first name followed by last name. So Python and Spark. Now there is other forms of passing arguments. What if you want to write a function that can take any number of values? You say pass the word. So you can pass anything to this function. So let's say you have a combination of non-default arguments A and B followed by a default argument name, and then let's say you have a function that has a signature like this and you want to print the type of C and also print the values in C. So in this case we want to define a function that can take any number of values. So how do we confirm that? Say I don't want to pass anything at the moment and see what comes out. So it shows the output is a tuple and then it prints an empty tuple as well. That means the type of the container holding all these values that we will be passing will be bundled in the form of a tuple, and it will also print all the values in that tuple if it has any. So now let's call pass the world with values like 10, 20 and see what happens. So in the second case, it does show 10 and 20. And what if I say 10, 20, 30, 40, and then also want to pass another 10 values by exploding a list. So it passes 10, 20, 30, 40. That's the actual value that we have specified. And then we also want to pass multiple values from the list to be bundled together in one placeholder, that is tuple in this case. So using asterisk notation, you can define a variable in your function signature that has the capability of taking any number of values from 0 to infinity. I mean, ideally that will also depend on the memory capacity of your system to hold those many values. But ideally, if you're not sure what all values can come from the external world to your function and how many of those would that be, then you can define a function like this. And while you look at this function, do you think there is any such function in Python that might have a signature like this? So print is one such function that has such a flexible signature. And now coming to another way of passing arguments. Extending that further, there could also be a signature that can help you pass any number of key value pairs. So in the previous signature that we have implemented in pass the world, if we say A, B, and C, and then followed by that, if I say asterisk P, and I don't specify D, E, F or anything. If we don't specify D and E and try to execute this, it says it got an unexpected keyword argument D. So even though we are passing additional values for 40 and 50, those are not being accepted by P. The reason is those are being passed in keyword notation and the signature of the function is not flexible enough to have any key value pairs wherein the keys, even if not defined as part of the function signature, could be accepted. In this case, it is only going to accept keys that have values A, B, C, or P. D, E, F will not be acceptable in this case. So how do we come up with such a signature? What if we say one more argument that says you can give it any name. Usually kwargs is the preferred name for such arguments in the function signature that can take any key value pairs. So if you supply A, B, and C with values, those will override these parameters that are already specified. But if you pass any other key value pairs wherein the keys are not part of the function signature, all the will get mapped to kwarg variable. And if we print that, it will show us all those details. So in this case, it prints 10, 20, 30 ABC values, and we are passing A, C, B, D, and E. D and E gets mapped to kwargs, and it shows up those. Since we did not pass any values that could otherwise have been associated with P, we don't see any values related to P. In fact, we are not even printing P. So if we print P, you will get to see it has no values. Now, how do we pass values in such functions that have combination of all these types of parameters? So we have non-default parameters, then followed by that we have default parameter. Then we have a parameter to take any number of values, and finally a parameter to take any form of key value pairs. We do have one such example here. So we have non-default parameter 1 and 2, default parameter 1 and 2, parameter to take any number of values, and then parameter to take any number of key value pairs. So I'll comment out this format name function here, and we will call master with all these values. So you'll have all these values until 70. Followed by that, we have key value pairs K, V, D, and P. So let's see what happens in this case. So 10, 20, 50, 90, they get mapped to non-default and default arguments. Anything after 90, that is 30, 60, 70, since these are plain values and there is no placeholder to take these values, all these get mapped to args argument, because that can take any number of values, arbitrary list argument, and then arbitrary key value pairs argument. So that's the name that we often use for them. So 30, 60, 70 get mapped to args, and that gets confirmed because in the second last sprint we have args 30, 60, 70, and anything after that, all the key value pairs, they get mapped to KWRs. Now what if we change one of the key value pairs to say D is equal to 3 and we are passing D as 30? Let's see the impact. So it says master got multiple values for argument D. The reason is the very first notation that is followed in mapping values to arguments is positional notation. So it will start from left and say 10, 20 definitely mapped to non-default arguments, 50 mapped to df1, and 90 will be mapped to D. However, when it was parsing arguments at the fag end, it also observed that D was specified as a key value pair as well. So in this case, it throws up this as an error. So if you have to pass any of the key value pairs, those have to start at a point when you do not have multiple values to pass. So as in this case, after non-default arguments, you can follow keyword notation here and say df1 is equal to 30 and D is already specified. So now when we run this, df2 is being printed and we have not specified df2. So that should take its default value. So in this case, 10, 20, 33, 3 as a default value for df2. And in this case, we don't see a complaint. D is equal to 3 again. We don't see any complaints because tuple would go blank, that is multiple values arguments, and all key value pairs will be mapped to KWRs as long as the keys are not part of the function signature. So we need to keep in mind what is the precedence of, or what is the order of mapping values within function signatures. So it follows functional notation, followed by multiple values to be assigned to arbitrary list argument, and then followed by key value pairs wherein any of the keys that are not part of the function signature, they get mapped to KWRs. So if you keep that order in mind, that's going to be followed across not only in these functions but also the methods that we write in classes, class constructors, they all follow same notation. So coming back to lambda functions and scope of variable. So what exactly is a lambda function? So Python initially came up with this concept and it was later made available in other languages as well. Now even there is onus on making Java completely functional. So Java until now has been following object-oriented paradigm, but then there are several benefits as part of the functional paradigm wherein functions can be treated as higher order functions or objects that can be passed as arguments to another function. So imagine writing a function, but then the argument to that function could be another function itself. So going by that flexibility in the language, we have the concept of lambda functions wherein we write anonymous functions. We don't assign a name to these functions, but rather just say a variable is equal to a function, and then we can even call that variable as if it was an original function. So this is the concept of functional programming wherein a function gets treated as an object and can then be passed to other functions as an input. So this is a signature of lambda function. We use the keyword lambda, followed by that you have arguments that are required for a function, and then you have colon. So on the right side of the colon, you have the definition of the function. Now, there are certain limitations when it comes to dealing with lambda functions in Python. First of all, you need to make sure that your function is only resolving a single expression. And then second, it should only be returning a singular value. And on the left side of the colon, you have function arguments, that is lambda x in this case. So x is the argument to a function. So if you were to read this in the form of a regular Python function, you would say define square x and then you would say return x square if x is greater than 10, otherwise return x cube. So this is how it has to be interpreted. Now we know that function signatures can really become complex and you can have non-default, default, arbitrary values and arbitrary key value pairs as arguments. All of that is supported in the lambda signature. So you can essentially say x comma y comma c is equal to 10. So you can have your lambda functions look like this, and you can also have arbitrary key value pairs and arbitrary arguments. So all of that can be defined on the left side of the colon separated by comma. Now, what exactly is the benefit of writing Lambda function? First of all, your functions become concise. You can have entire definition of the function in one single line. But in addition to the simplicity of defining this, at times you are in a scenario wherein you don't want to get down to writing a simple function like this, following a signature and then writing the return statement. It can be simplified to be written in one single line. Then why to go with the actual syntax of the function definition? So in those scenarios, you use Lambda function, and this is very important because when we touch upon Spark and do PySpark exercises, you'll see Lambda is heavily used. So we have defined our first Lambda function and assigned it to variable square, sq, and if you pass any value to sq, it will work as if it's a function. You say sq of 3, you say sq of 30, so value is greater than 10, it should return the square of the number, square of 12. And if you have a list of values to be classified, let's say you have marks as a variable, I believe that would have been created above. So when we have marks as the variable, that looks like this. It has a bunch of values, and if we are to categorize marks, so we say, if we write a function wherein we say mark is greater than 70, we call that as a perfect mark, otherwise we say it needs improvement. And then how do we get to see if values and marks are getting translated to perfect and needs improvement? We iterate over marks list and pass every individual mark value to categorize marks function. And this is how the output turns up. Improvement in first two values, next two values says perfect, and then again last two values as need improvement. They could not be a negative mark. And now we want to simplify this. So we want to implement the categorize marks definition using a lambda function. So how would that look like in lambda? We say lambda x, wherein x will be every value taken from the list and passed as an input to this function. And what do we want to do with that particular value? We say if the value is greater than 70, then prior to the if we say perfect, else we say needs improvement. So lambda functions, first of all, cannot have if statement involving else if as well. It has to be just two forms of if and else that can be followed as a simple expression. And then how do we map all marks to this lambda function? So we use the map function in Python. Map has the ability to say provide me first argument as the function and second argument as an wherein every value in the iterable needs to be run through this function. So map simplifies our job. So we pass lambda function as first argument to map and second argument as the marks, and map will actually return an object that needs to be iterated to get all the values. So we bundle that in the form of a list to see the output, and when this is run, you will see needs improvement, perfect, perfect, needs improvement. It includes the last one as well. Similar to the map function, you can use filter function. The signature of filter function is similar. You pass first argument as a function and second argument as an iterable. The difference between map and filter is map ensures every value in the iterable is transformed by running over this function. So it will return you a list of the same length as the list of inputs that you pass here, as long as there are no exceptions in doing that. So in that case, it will actually fail. But if it runs successfully, the length of list will be same as the length of iterable will be same as the length of iterable that you have passed. But in case of filter, you may get either the same number of values in the iterable that you pass, or you may get lesser number of values because it runs every value through the conditions that you specify in this lambda function. And if it evaluates to true, the value is considered. If it evaluates to false, the value is not considered. So in case of such filter functions, instead of writing output like perfect and needs improvement, we just have to implement a if condition. So we are saying the value is in the range 50 to 75, or if the value is less than 10 or it is greater than 80. So if it matches any of these conditions, either in this range or outside these boundaries, it will evaluate to true. So let's see which are those values that match this condition. So 54, 99, 81 and 3. So 54 is in 50 to 75 bracket. That's true. 99 and 81 are in the second condition wherein we say mark should be greater than 80. So those are met, or it should be less than 10. So -3. But what about other values like 45 and 12? So 45 does not fit in the first bracket, and in the second one, it's not between 10 and 80. So it should be below 10 or greater than 80. Similarly, 12 is dropped because it does not meet any of these conditions. So this is a very concise way of filtering values. Now, whatever we have implemented in these two cases can very well be converted back to a conventional function and a for loop. So you say for mark and marks, run off for every value in the marks iterable, and then you say create another list, keep that as an empty, and check if marks matches any of this condition, then you append the value to that list, otherwise you don't do anything. And once your for loop has completed running over all the values, the list that you are preparing, you will see this as an out. But then why to stick to that verbose format when all of this can be simplified in one single line using concise functions like list, filter, and lambda? Similar to map and filter functions, there is one more function called reduce. So reduce can be used to aggregate values over an iterable. Now you can decide how do you want to reduce values, wherein do you want to add all the values or multiply all the values. So while we run through this exercise, so in order to use reduce, you have to use functools library. That's a standard library. You don't have to install it explicitly. From that, import reduce function and say lambda x comma y. So always reduce will have two arguments, x comma y, and then could be more than that as well. And then you define what is it that you want to do with the reduce function. In this case, we want to multiply. We are passing a bunch of values and we are generating that using the range function. So 1 to 5 starts from 1, ends at 1 short of 6. So 1 2 3 4 5, and we are saying x has to be added to y. But then how does the addition actually work, and how does two values get passed to reduce function? Because until now we have seen only single value being passed in case of map and filter, and we were just passing an iterable. We are doing the same thing in range, but how is it taking two variables at a time? So the way reduce works is when the first value is passed along with the second value, so it will take from the iterable, it will take initial two values and pass it to the reduce function, perform addition on those two values, and save the result of that addition to the x variable. And there onwards, it will take one value at a time, or rather, I'll put it this way, it will take one value as x and that becomes the final value of x. Second time it takes 2 and assign it to y, but then it notices that the value of x is already 1, so it will say x is equal to x plus y this time. So x becomes 3, and then it loads another value from the iterable, that will be 3. So 3 gets loaded in y, and then we say the value of x by now is 3 and the value of this time y is also 3. So we say again x is equal to x plus y, so x becomes 6, and then it again loads 4 and 5 subsequently. So every time the intermediate result of the add gets stored in variable x. So that's how it maintains its state internally and performs the reduce operation. So now how to generate the factorial of a number? And factorial of a number is if you pass 5, it should be 1 into 2 into 3 into 4 into 5. Similarly, any other number. And there is this concept of generator that we haven't looked at until now. So generator are such objects that are returned from a function in the form wherein you have an iterable specified, but you don't get the values from an iterable. So it's as good as saying when we create a list and have all these values 10, 20, 3, 4, 5, all of this gets saved in memory at once. So if there are 1 million elements in the list, you require that much memory to hold all these values. But let's say you are reading data from an external source or from an external API that says I can return you values one by one. But because you are only familiar with list until now, so you'll say, okay, why not? I'll create a list, and then as and when I get value from you, I'll keep on adding to the list. But that way you will end up exhausting your memory at a point in time if the external source supplies too much of data. So what is an efficient way to deal with these scenarios? So let's say the external source supplies this list and it supplies you values in the form of one element at a time. So to deal with that, you'll say for x in L1, and then instead of adding those values in another list or returning those values, you say yield x. So yield is a very popular term in Python and you should know how to use it. And it's often used in combination with list. In this case, we have marks. And let's say we call this as a function f1, wherein it iterates over marks and is yielding value 1 at a time. So when we execute f1, let's see what output do we get. We get a generator object. So it did not return the values. Where did the values go? So it says there is an object called marks in the memory. I am pointing to it as an iterator, but I have still not started fetching values from that. So if you want any values, there are two ways to get it. So one option is you can say for y in f1 and say print y. So the benefit of this is now you will say you were trying to avoid a for loop, not getting all values in memory at once, but you are doing the same thing. It appears to be that, but it is not. So it is trying to retrieve value one at a time from the marks list without saving any of those in memory. So the memory footprint in this case will be equivalent of having only one single value in memory. So when you even run a for loop, it will take one value from marks and then it will have a pointer to know what is the next value that it is supposed to fetch. So it fetches all these values in this order. So in this case, when you have functions like this, they return generator, and this is how you iterate over them. The second way is you could also say enclose all these values in list, but then that defeats our purpose. So in this case, we are building a list wherein all values from the generator will be fetched and maintained in the form of a list. In this case, we should see two output. One is the entire list representing all these values, and the second is the for loop that we have implemented. Now, why did we touch upon generators? Because map and filter functions return generators. And if you want to verify that, let's say you want to still categorize marks. So yeah, we use directly Lambda function with map and list as the combination. But you can also supply a user-defined function. So if your function is written in a way wherein it cannot be maintained in just one single if and else block, but rather it's a very complex function that takes value from a database and then there are multiple if else conditions, then you'll be better off defining that as a function, but you could still use map with it. So instead of passing first argument as lambda function, you can pass a user defined function and then pass marks. So every mark from this marks list will be taken out and then supplied as input to categorize marks. So when we run this, we get map at this. Map is a generator function in this case, and in order to get all values, you can either run a for loop or convert them to list to see the output. So that brings us to close of lambda, and we are only left with built-in functions. So I'll quickly run through some of these. Built-in functions are those functions that are readily available in Python and we don't have to import any library to use these. One such example is the open function that we have used to look at files. Then there is dir function that deals with the namespace. You have absolute function to get the absolute of a value. It converts negative to a positive value, and if it's already positive, no issues. Then we have sum function to sum a list of values, but then it takes a list as input. We have chr function to convert a number to its ASCII value, and we have integer function to convert a fractional value to corresponding integer. We have any function. Now this is interesting. Many times you get a list of values, but then you want to make sure that there is something that is there in those values that matches a criteria. In case of this any function, the criteria is there a single non-zero value in the list? So if you say any of marks, in fact all of these are non-zero values, so it returns true. And the opposite of any is a strict version of any is all, wherein it checks that all values in the list are non-zero. So even if there is a single value in the list that is zero, it will evaluate to false. If we say marks this, and now if I say marks dot append 0 and then execute all, you'll get to see false. So in certain conditions, any and all are quite helpful, especially if you are receiving input from an external source and you want to validate that. You can also reverse the list using the reverse function, but then reverse is not an equivalent of reverse sorting. If you say sorted of marks, it will sort the marks list, and if you say sorted of marks and reverse is equal to true, it will sort the list in descending order. But then reverse is only going to reverse the position of elements, start reading the list from right to left instead of left to right. Now reverse function would also return a generator. Generator is heavily used in Python for optimization purposes, wherein you don't have to explicitly state every time that I'm not going to prepare a huge list, but rather interpreter tries to be smart enough to say why to create a list when we can help you iterate over that in a more efficient way, exposing a generator, and then you can choose whether you still want all of that as a list of values using the list function, or you just want to iterate over that value by value using a for loop. We have seen octal function, hex function. Bin function is used for converting a number to a binary, and then it has 0b as prefix. So 0 was for octal, 0x for hex, 0b for binary. So binary 4 is represented as 100, binary 2 is represented as 10, and binary 3 as 11. So you can confirm that. And we have seen how to interpret a hex number as an integer. You just have to save it to a variable, and when you print the value, it will automatically be printed as the equivalent decimal value. So these are couple of built-in functions, and the list is very huge. So Python is an object-oriented language. It's not only object-oriented, I would say it's functional as well. it supports procedural programming also. So Python is an object-oriented language. Because of this, creating and using classes and objects becomes easy. So because of this feature, it supports creation of classes and objects, and data becomes active using this paradigm. Code is reusable and thus lesser code have to be written. Object-oriented paradigm also gives us the ability to simulate real-world events much more effectively as opposed to trying the same thing in procedural or functional paradigm. And programmer is able to produce faster, more accurate and better written applications. So object-oriented paradigm is helpful in several cases and especially in the context of some of the features that we have learned. It helps in simulating real-world events and objects, wherein the other two paradigms do not have as better ability as OOPS has. However, many a times you might only require functional paradigm, or functional paradigm might serve the case better as opposed to OOPS or similarly procedural paradigm. So the best part in Python is it does not restrict you to use only one of the paradigms at a time. That essentially means you can have a script that has classes and objects in it. Within classes and objects, you can follow functional and procedural paradigm, or your script can follow any of these paradigms in combination within a single script. So let's see this paradigm as well. The functional paradigm we have already learned through the use of Lambda function, and later on we'll combine all three together in one or the other form. So in Java, the limitation, and Java we all know is a very popular programming language. However, it only supports one paradigm of programming, that is object-oriented programming. So the limitation is in Java we cannot write a single piece of code without using classes. But in Python we can do that. Even many projects don't even require the use of classes and objects. So it's completely up to us to decide whether something has to be written in the form of a class, or we can plainly write a Python script that is just a combination of few functions, or a loose script without even functions, which is otherwise not possible in Java. You have to have classes and objects. So Python is an interpreted language. It executes code line by line, and if the program has some error, the error will be shown when a line of code gets executed, which is not the case in Java. So let's say you have this use case of a multinational company that wants to create employee information sheet that includes attributes like name of the employee, the ID of the employee, and their progress. And they want the progress to be defined weekly and monthly. However, it is easy to infer that when you want to track progress, probably the parameters to evaluate that would remain same on a weekly basis as well as on a monthly basis. And in fact, monthly progress could be an aggregation of weekly progress put together. So if you have to implement such a software in Python, probably you will not have to write code separately for weekly progress or for monthly progress. If you design it well, you can follow object-oriented programming and create a class for tracking progress at a weekly level, and then create a class that is tracking progress at a monthly level, but it could be an extension of the weekly class to say that I'll utilize all the parameters defined herein and basically sum up all the weekly information at a monthly level. So how will it be different to create a separate sheet for every employee? And so first of all, that was one case wherein we want to reuse the code from a weekly progress report over a monthly progress report. And secondly, we do not want to create a progress card for each and every employee separately. So we will create one class to hold employee information and create object of that class for every employee whenever a new record has to be generated for any new employee. So imagine this as iterating over a bunch of employee information records in a database table, taking one record after the other, and as and when you pull information out of the database, you create a Python object out of that, and that object is an object of the employee class that you have created to hold that information, and you pass employee information to another class that is used to calculate weekly progress of an employee. Thanks everyone once again.